unit and the actual cell tower. And yeah, we're not going to get into really that. That would really be more of an RF, a radio frequency type of class. We can look at first generation was an analog signal, just like FM, frequency modulated signals. The second generation systems were what's known as TDMA, time division multiple access, and we'll at least define at a high level what TDMA is. Third generation, you went into something called wideband CDMA, code division multiple access, and then there was a synchronous CDMA in the fourth generation. So it really depends on the generation. But the focus of what we're going to be doing here is going to be more on the network side, the architecture, rather than on what's on the air interface. So yeah, I'll talk to Richard and maybe something else on the actual electromagnetic waves, but that's really an RF, a radio frequency type of course. Okay.
All right, that makes sense.
Okay.
I
Good.
believe we
Good.
can
Good. Good.
carry on.
Now, thus far, we've covered. We look at the top layer here. We looked at the industry, kind of an overview of the industry. We looked at identities. I know that might have been a little bit confusing, but you're going to see identities more. We're not, just because we talked about them doesn't mean we're not going to see them again. But just keep in mind that there's many identities in the for a mobile. Kind of the most important one. There's a couple of them. One, of course, is your telephone number. That has the name MS, mobile station, ISDN. It's a strange name. I won't argue that, but mobile station ISDN, that's your actual telephone number that family and friends use to call you. The other, though, very important identity you have is called your IMSI, your International Mobile Subscriber Identity. And that's the way the network finds you. That's the way the network bills you. That's the way the network pages you. Anything the network needs to do anything to find you, to register you, to update your location, to page you, to hand over anything is done with this International Mobile Subscriber Identity, this IMSI. In terms of the type of digit, it's what's known as an E.212, and it's made up of your mobile country code and your mobile network code, and then some kind of identifier, mobile station ID. So it uniquely identifies you. And when you power your mobile phone on, it's that IMSI that the network uses to find your home system, because it needs to find your home system. And we're going to look at call flow scenarios in later lessons, but that IMSI is what it uses to find you and to update your location. Your IMSI is not known by you, though. It's on your SIM card and it's in your home system, but it's nothing that you can access. It's nothing that you can look at, or here's my IMSI. It's a kind of think of it as kind of like a secret number. So we went over the identities and we ended up right here. We ended up talking about the different generations. So we said there's what are known as generations. It started off in the 1980s, and that was what they called first G, or first generation. And that was kind of just a basic build out of the network. I mean, mobile networks were not around then. So in many areas and many parts of the world that did not have mobile phones in the 1980s, they just never had a first generation. Second generation was in the 1990s. This was digital now. Your air interface was a digital signal. There was a lot more sophisticated switching. Security was starting to be thought of. So that was all second generation. Third generation now was the start of this brand new thing called the World Wide Web, and people were actually exchanging data. So third generation, like maybe pictures, perhaps things like the documents. It was still too slow, though, to do things like video. Fourth generation was now the 2010s. It came out like 2008, 2009. But if you think of the every decade as a generation, the 2010s was the fourth generation. This was high speed data. So now you could download videos and so on. And now into the 2020s is what is 5G. Now, just because 5G is here doesn't mean that 4G has gone away. Just because 4G is around doesn't mean that 3G. There's 2G, 3Gs out there. Some networks have second, third generation, fourth, and doing part of fifth generation. So I think it's important to understand what these generations are, and we'll take a look at the first generation only from a historical perspective, but then we'll get into the second generation and what changed there, and then the third generation, and then we'll concentrate on the 4G and 5G is where we're at today. But rather than jump right into here, it's important to understand this because regardless of the generation, there's still certain things that have to be done. You need to update your location so the system knows where you're at. You need to provide for handovers. You need to authenticate. You need to manage the mobile. So there's functions that have to be done, but they're done differently. And just as important, they are done using different signaling protocols. In some cases, you'll use what's known as signaling system 7. In some cases, diameter. For data, you'll use something called GPRS tunneling protocol, GTP. For voice over IP, you use SIP. So again, there's a lot of different signaling methods throughout these different generations. So we're going to go slow enough that hopefully it makes sense. If you have any questions, either let me know or I'll kind of glance at the I have my chat window open here, so I'll kind of glance at the chat window and otherwise just let me know. So we went over this last time, and if you look at the eras, and it really goes the 1980s to the 1990s. Yeah, please. Sure. Signaling is what these network elements do to talk to each other. So if I fly over to Accra and power my mobile phone on, the company in Accra has to send messages, data messages back to my home system to get information about me. Those are signaling. It's done when you're roaming, but it's also done when you're in your own home network. So if you're in your own home network, occasionally you'll go into a different switching area. So the signaling has to take place. The network is going to try and authenticate you to make sure when you place a call that is really you. So signaling is any time a telephone switch, think of a switch as the device that is interpreting the digits that you put in, and it's going to select a route to try and route your call throughout the world. In the mobile environment, though, in the mobile networks, it needs to do more than just interpret digits. It needs to also send messages to other network elements, to things, so it can authenticate you, so it can know who you are, so it can deliver short messages to you. Anytime a switch needs to go outside of itself, think of a switch as a physical location. Anytime it needs to go elsewhere for information, that's going to be signaling. Okay? So yeah, that does make a big difference. So throughout these eras, the 1980s, the 1990s, into the 2000s, the 2010s, and the 2020s, you've got different generations. Now they're called first generation phones and second generation. Then there's kind of in between generations, things like 2.5 generation or 2.75, almost 3G. Then you got third generation, 3.5, 4G, and so on, up to currently 5G. How these networks were used differs a lot. For example, back in the 1980s, you used your phone strictly for voice. There was no sending data. That this was I had my first mobile phone back in 1987, and at that time we were absolutely thrilled just to be able to have a phone that wasn't in your home. So voice was the only thing that the phones were used for back in the 1980s. Second generation, the 1990s, there was some data there, but again, it was very slow data. Maybe a document, maybe reading an email, but again, that was a little bit of data. Packet data, and we'll define what packet data is. Packet data came out in the mid to late 1990s. This is where you could now use the network to download, let's say, a document, download a Word file, download some some small amount of text. And then the network would give you all kinds of resources until you downloaded that on your phone. Well, now when you read that document, it released those radio resources so others could use it. But it gave you a whole bunch of resources for a short period of time while you downloaded, let's say, a Word file. And it was a little bit faster by the late 1990s. Then came what's known as third generation. This was very, very late 1990s, almost 2000. It was called 3G or third generation. Data was a little bit quicker now. It was, you can now download some pictures, some like photographs or pictures. Again, not video, not that quick yet. That really kind of stayed on. They had high speed packet access and so on, but until it got to the fourth generation. The fourth generation was really needed for data because I think it was 2008, might be off by a year, but in 2008, Apple introduced the iPhone, and people were buying these phones for the purpose of data. And the third generation systems back then, they couldn't handle it. They were, they were, phones were being blocked because, again, they couldn't handle the amount of data. So a whole new architecture came about in 2000, roughly 2009, 2008, 2009, almost to 2010. A whole new architecture came about, and that was able to handle all the massive amounts of data, and not just data like pictures or Word documents. This is data with video, and which takes a lot of bandwidth. It takes a lot to put a video on your phone. You could never do that back 20 years ago. Back in here, you could never. If I tried to download a video right here, I might as well start the download and go to bed and get up in the morning and maybe be done. It was that slow. But now today, it's kind of child's play. Then you get the 5G. 5G has other uses besides faster data, faster broadband. So these were the uses then. Strictly voice, little bit of data, little more data, voice and data together, video. And now in 5G, you got these kind of strange acronyms: enhanced mobile broadband, faster and faster data. But you also have machine to machine communication. Machine to machine communication is all these, think of just thousands of sensors out there that are measuring traffic, they're measuring pressure in a water pipe, they're measuring amount of cars that go past a certain point. All these sensors that are measuring things that are using the cellular network. That's machine to machine communication. It transmits just little amounts of data, little amounts of data, and just very sporadically. Again, think of a pipeline. Think of a pipeline in the most remote places of Ghana, and this thing is out there just measuring and giving little bits of data occasionally just to measure things like pressures. The other use of it is ultra reliable, low latency communication. This means that this is things like maybe robotic distance surgeries or things like self-driving cars, things where you can have very, very low, you have to have very, very low delay. Delay is called latency. So very, very, it has to be instantaneous. If you were doing a robotic surgery from a distance over a different city, as you did something in one, it would have to be instantaneous at the other end. So these are some of the uses of 5G. 5G is more than just faster data. Up until 5G, everything was always faster data, faster data, faster data. But now with 5G, it's faster data plus other uses. The other thing is how do all these devices communicate with each other? That's the signaling. That's different, and there's different methods, and that's called a protocol. A protocol is just we agree on something. If I agree to teach you in English, that's the protocol we're going to use is English. If I said, okay, we're going to learn this in French, French would be our protocol. Well, protocol is the language that these devices use to communicate. Some of these use what's known as Signaling System 7. That's a telecommunications protocol. Some of them use GTP. Let me silence my phone here. Some of them use GTP, GPS Tunneling Protocol. This is for sending data. Some of them use diameter, some of them use SIP, and we're going to define what each one of these are as we go through this. Some of them use all of them. Some of them go back to internet protocols. HTTP is an internet type of protocol, hypertext transfer protocol. So the telecommunications networks today have kind of a wide variety of different forms of data and how they send data. It depends on the generation. It depends on what data you're sending and why would you send data. Ralph said that right at the beginning. Why would you send data? Well, it's the network has to keep track of you. The network has to know where you are. The network has to know something about you before it allows you to even use the phone. So this is just kind of a high level overview of the different generations. If we start off way back in the 1980s, you had first, yeah, please. Yep. Yeah, two-way really came about in the first generation. Before that, you shared radio. So if we shared a frequency, if I shared a frequency, let's say I'm talking on a radio to Raphael, and if we share a frequency for our voice, I would have to say, "Hey, Raphael, how are you today?" Over, and then he would talk because we're sharing that same frequency. But with telephony, I want to talk and he wants to talk at the same time. That takes two different radio frequencies. That takes a radio frequency for me to transmit up from my mobile phone up to the cell tower, but it also takes another frequency for me to listen from the cell tower to my mobile phone. And same with his end. He's got to talk on one set of frequencies and listen on another set of frequencies. That's what's known as duplex. That's full duplex. But that came about in first generation. But first generation phones, there were many different networks, many different systems out there. And I listed some of them. And here's some of the things about the first generation system. First of all, it was analog. What do you mean by analog? Well, that means it was just like listening to an FM radio, a frequency modulated radio. My voice was not digitized. When you talk, when I'm talking right now, I'm talking analog. Once it hits my receiver, my transmitter here, it gets converted to a digital signal. And it goes digital all the way to your classroom. At your end, it's converted back to analog because you listen analog. You can't listen with zeros and ones. Did analog, you listen analog, but in between, it's digitized. But in second generation system and first generation systems, from the mobile phone up to the cell tower, that was analog. Today it's all digital. But back then it was all analog. The first generation system established mobility. For the first time, people could actually take a phone and drive across the town and talk on their phone. That was not done prior to mobile telephony. Your phones were tied to your home. They were tethered to your home. There was no such thing as taking a phone out. You might have had a cordless phone, but that was just a short distance. You could not take your cordless phone and drive across town like you can with a mobile phone. All of the initial frequencies were allocated in first generation phones. Most of your frequencies in first generation were either in the 400 or the 800 megahertz range. That's kind of that's kind of a lower frequency, 800 megahertz. Today, that's where you get some LANs are in there, some TV is in there. That's remember we talked about different frequency ranges. That's a very desired frequency range, is the 800 megahertz. Also, the networks did the initial build out. What do I mean by initial build out? The cell towers. I mean, prior to the 1980s, there was no cell towers anywhere, very few. So it there were some setbacks or some things to overcome on the first generation system. First of all, it required a lot of frequency. When I talk to you, it takes a chunk of frequencies, not just one radio wave. It takes a lot of radio waves together for me to talk. Otherwise, you would never understand me. I can't be, if I have a large chunk of frequency, it can't be right next to another large chunk of frequency. It would bleed over. So we have to have gaps in between there. So it took a lot of frequency to make first generation systems work. So if you look around the world, I just listed some of the countries here in the world, and they had all different systems. AMPS, Advanced Mobile Phone Service, Nordic Mobile Telephone, Total Access Communication System. I don't know what RTMS is. They worked in different frequency ranges, different frequency. And when I talk frequency range, let's see, we are on, I'm going to go back one. So you understand the frequency. I'm going to go back here. This is what we mean by frequency. Some was in the 400 megahertz range, which is down right around here. Some is in the 800 megahertz range, which is a little hard. This is in what's known as the ultra high frequency band. That's in the radio. Today, this is where TVs, microwaves, LANs, Bluetooth, two-way radios, cellular, all these things work in this. This is a very desired frequency. What do I mean by desired? It means that that's a good frequency that goes a long distance, and it can go through walls, it can go through windows. You don't need cell towers everywhere, because at that range it'll bounce off objects. The higher the frequency you go, the more radio takes on the characteristics of light. It becomes more focused, more beamed, and it doesn't go as far. It dies out much quicker. So the higher frequencies, you can have higher data, but you need more cell towers because it doesn't go as far. The lower frequencies aren't as quick on data. They're okay, but not as quick on data. However, they can go a longer distance. When you get down to frequencies like this, you can send signals that follow the curvature of the Earth. They're a very low frequency, and they'll follow the curvature. So kind of a desired frequency, kind of a middle of the road that satisfies the fact that you don't need cell towers everywhere, and it goes through walls, it goes through windows and so on. That's this frequency range, the ultra high frequency range. So that's what we mean by desired frequency. So again, there were different frequency ranges, and they were launched back in the 1980s. Now, what these things had, though, every mobile generation has always the same thing, three things. You need what's known as a user equipment. You need what's known as a radio, and that's called the RAN, R-A-N, Radio Access Network. And you need equipment in what's known as the core network. The core network is what is your telephone switch. Your telephone switch is what interprets digits as you dial digits. It's to keep track of you. And it does this with databases and with registers. And we'll talk about these registers. Some of these registers are for visitors. That's called the visitor location register. Some of these are your central database that knows about all your services. That's your home register. So if I come over to another network and I power my mobile phone on, my identity is going to come out here. The switch is then going to ask its internal register, hey, do you know who Steve is? If it doesn't, it's got to go find my home system and ask my home system, do you know who Steve is? And if you do, tell me something about him. Tell me what services he has. And we're going to talk a lot more about that. But just keep in mind right now, these first generation systems, there were many, many different kinds of systems. It wasn't until second generation systems that things like roaming, things like being able to move about and doing things like roaming came about. So if you look at analog cellular, just pure analog cellular, like I was talking with Ralph just a few minutes ago, you need two separate ranges of frequency. One is called the uplink. The uplink is when this guy right here wants to talk. That goes on an uplink frequency. And when he's listening, it's on a different frequency. That's called the downlink. And they're separated. So that you have to, when you talked on an old analog phone, you'd have one frequency that was you were talking on, another one you were listening on, and the other end was doing the same thing. They were talking on one, listening on another. That way we could have what's known as full duplex. And these were all channels, and these channels had a width. They had a width of roughly 20 to 25, what's known as a kilohertz. So just think of a frequency, and it's instead of just one exact frequency, there's like there's a couple of thousand of these frequencies that are just right next to each other. Well, that's what you're actually talking on. You're talking on frequency. If it's digital, that would be digitized. We'll talk about what that is also. But these first generation systems were analog. They were all analog. Just an analog is like you listening to the FM radio. When you listen to a frequency modulated signal on a radio, that's analog over the air, and it's analog, of course, in your ear. Now, by the late 1980s, getting into right around 1990, 1991, there was motivations to improve things, to go from a first generation to a second generation. There were several second generation systems. The one that really became kind of the worldwide predominant standard was called Global System for Mobile Communications, GSM. It was a European initiative, but there were others. So why go to a second generation? Well, these are the reasons. Increased demand. People wanted more and more and more. More people wanted mobile phones. Digital switching, the switching equipment itself, in the core network was now more, the core network was digital. There were the analog systems of the 1970s and 80s were being replaced with digital systems. There was a need to digitize the voice. There was a need to take this signal, an analog signal in this direction, an analog signal in this direction, and digitize it. In other words, make it zeros and ones. Just make it into a digital format. There was a need to decrease the size of the mobile. The early mobiles in the 1980s, these things were huge, and the battery life was nothing like it is today. So you had a big, heavy phones. Well, there's a need to increase the battery life and increase capacity. Instead of dividing everything up into frequency, you also divided everything up into the time domain. We're going to talk about that on Friday. There was a new technology, code division multiple access. So now we have frequency division multiple access, time division multiple access, code division multiple access. Roaming was something that was new. Texting was. So these were all the reasons for a second generation system. And this is where we're going to pick this up on Friday. We'll pick this up looking at second generation, and we'll look at what are these air interfaces, what is FDMA, TDMA, CDMA, and then look at second generation systems, what's needed, and what are the signaling methods. That's a very important thing. Questions?
Yes. Okay, Steve. When it comes to the frequencies, we've realized that there are only limited frequencies we do have. But I was wondering if these frequencies, they can be in a form of decimals. I want to get a concept really well. So let's say if we have, like, let's say 3.7 gigahertz or something, could there be a frequency like that? And if it can, there can be decimals in it, then why should it be limited? Was my
Nope,
question
you're
clear?
no, I can see your mouth, but I don't. I'm like, say that one more time because I only heard every couple
Okay.
words there.
Okay, so what I mean is, if we have limited frequencies, uh, do we use decimals in frequencies? If so, why should there be limited bands or frequencies?
Why? Yeah, because these frequencies are not only desirable for mobile telephony, but other users want to use these frequencies. So when a mobile company is allotted frequency, no one else should be able to use that. But yet these are very desirable frequencies for point-to-point microwave, for private operators, for pipeline companies. So the frequencies are very, you can't just go out and use any frequency. It's a government organization that allocates these frequencies. Otherwise, you'd never be able to do it. So the government says, okay, your mobile telephone company, let's say Vodafone in Ghana, Vodafone is allocated certain frequencies. That's what they have to use. And it's very difficult to get more frequency, very expensive, very difficult. So what they do is they try to make the best use of the frequency they have by different modulation techniques.
Okay, yeah, I sort of get that, but where my problem stems for is, could there be a frequency like 3 gigahertz and then 3.1 gigahertz and 3.12 gigahertz? Could there be something like that?
Sure, sure. You can have different frequencies. You can, but again, this is what you need right in here. You can
Okay,
get more. I mean, there's frequency maybe up in here, but the higher the frequency goes, the quicker the signal dies down.
okay,
It it's it forms more of a beam. The lower the frequency, the more it goes further, but you can't you use high speed data. You can't. This is good for certain communications, but this is terrible for data. This is great for data, but it doesn't go very far. This is the most ideal range right here, but everyone wants that.
oh, okay,
Everyone wants that frequency. So most cellular today is in the 800 megahertz range and the 1.7, 1.8 megahertz range. So kind of in 800 megahertz is right here, and 1.7, 1.8 megahertz or 1700 megahertz is roughly right here. So kind of in this frequency range, all in here. There's some that are a little bit lower. There's some that's for 5G that's going to use up here, but that's a very high frequency. It's called the millimeter wave band. So yeah, it's just the general property of radio. Like I said, there's frequency you can get down here, but you can never use it for data. Never. It's terrible for transmitting data. This is great for transmitting data, but it doesn't go as far. The higher the frequency, the less the signal goes. Yeah. This is ideal because you don't need cell towers everywhere. If all of our frequency for mobile telecommunications was up in here, that's all you'd see. You'd see cell towers everywhere because it doesn't go that far. Okay, very good. Let me mhm, mhm. Yes, walkie-talkie would use half duplex. Yep. There are some applications, maybe sensors that only need to talk one way. If you have a sensor that's measuring, pressure, you don't have to communicate with it. It's a one-way communication. So you could have that type of thing. But for telephony, mobile telephony, and for using your phone for data, you want to transmit data, but you also want to receive data. So you need duplex. You need both of them. Same with voice. You've got a voice. You have to have full duplex. So you need two different channels basically.
I would like to get something clarified. So in the UFC spectrum, like the government allocates specific bands to certain networks, so they tune their cells to those specific networks, like to those specific bands. So
Yeah, and
like
it really is
network.
that's going to vary from country to country. In the United States, it's called the FCC, the Federal Communications Commission, and they allocate, what frequencies anyone can use. So some frequencies are used for railroads, some frequencies are used for public land mobile. Some, they allocate all these who gets to use frequencies because you can't everyone can't use the same frequency. Now if I had a license here and where I'm at and 1,000 miles away, someone could use a frequency. Yeah, that's different because you're using the same frequency, but the distance is a long ways away. But radio stations all have to have licenses for different frequencies they operate on. AM radio works down in this range. FM radio works down in this range.
Okay.
Okay. If you do have any questions, please send me an email. Otherwise, we'll see you on Friday. Okay, I'm gonna stop this over here, and I'm gonna put you. Let's see. I'm gonna close this out here, and I'm gonna move you over to my front here. There we go. Now you're in front. Okay. Enjoy the rest of your day, and we'll see you on Friday.
See you.
Okay. Thank you, everyone. Have a good day. Have a good rest of the class.